Hello, and welcome to the second session of the Biodiversity Information for Development workshop on data mobilization. This workshop is funded by the European Union and coordinated by the GBIF Secretariat. My name is Sharon Grant, and I am the Technology Liaison to Science at the Field Museum in Chicago. I'm going to use a presentation to help me during this video, and I'm going to start it now. This session is foundation work, and for those of you who managed to get through the online pre-course activities, a lot of this should be familiar to you. So what we will do here is give you some more background and bring you back up to speed with some of the language and terminology that will flow through the rest of the course. The structure of this session is in 5 parts that are connected in a number of ways. Data quality, that you will see a lot of during this course, is pervasive and important. Documentation at a number of different levels is important and will help you to understand why and how to do it. Standards. Obviously, you are here because you want to be standard and do things in a coordinated way. We will attempt to help you do this. Data normalization is a methodology that we will use to help you understand your data and ways to organize it to make your life easier. Lastly, we will discuss why to publish and give you some words and phrases to help you convince people that it is a good idea and that they should help you. So, let's talk about data quality. This quote from Arthur Chapman's 2005 GBIF white paper, Principles of Data Quality, is really the Bible for this topic, and taking some time to read through it will stand you in good stead through your project. This is how he defines data quality. Data quality is related to use and cannot be assessed independently of the user. In a database, the data have no actual value, they only have potential value. And that is realized only when someone uses the data to do something useful. Information quality relates to its ability to satisfy its customer and to meet the customer's needs. In essence, what he is saying is that data quality is relative to its intended use. What is good for a geographer may not be so good for a microbiologist. There are 3 main criteria that are used to describe data quality: fitness for use, accuracy and precision, errors and uncertainty. Let's look at each of these in more detail. Firstly, fitness for use. No data is perfect and no data set completely without errors. Never assume that it is. To help you, there are a number of parameters that you can use to describe your data and help a user decide if it is going to be useful for their particular purpose. Firstly, accessibility. How easily can someone get to your data? You can't use it if you can't find it. Secondly, accuracy. Can you trust the data? For example, are identifications by a trusted expert? Do georeferences contain datum information? Thirdly, timely. Will the data be available soon enough for it to be of use to you? How often is it updated? How out of date has the data become? Fourthly, completeness and comprehensiveness. Which part of the data are fully fleshed out? It may be taxonomically comprehensive, but it may not be geographically comprehensive. Consistency. Is the data in each field always the same? For example, are all dates in the format day, month, year? Relevancy is important, and it's how similar this data set is to others that have been used for the same purpose. Is it detailed? How much resolution is there in your data? For example, at what scale can it be used to map species distributions? Lastly, how easy is your data to read and interpret? Is the data set documented in a clear and concise way? The key point here is, do you understand your data and can you explain its purpose to someone else? Second, accuracy and precision. These are to do with how confident you are in your results. Accuracy is about how close you are to the true value. If we look at the top example, the points are pretty close to the center target. We would say here that the user has shown a high degree of accuracy. In the second example, at the bottom, we look at precision. And this is to do with how consistent your measurements are and how close to the true value, not how close to the true value they are. In this case, we see that the black points are clustered to the bottom left of the diagram. They are very close together, and the user is obviously very precise. However, they have not been so accurate. Next, we'll look at uncertainty and error. Uncertainty is the quantification of doubt about a measurement. Here, in the top example, we look at 2 test tubes and see that the measurement of the amount of liquid in the tubes is the same. However, example A is an underestimate, whereas example B is an overestimate. You would need to be able to explain this degree of uncertainty to your users. In the bottom example of the targets, we see 2 types of error. To the left, systematic error. Here, the points are very close together and in the same error. However, they are incorrect by a similar amount on each attempt. On the right, we see an example of random error. Each point is distributed randomly across the target. So these are 2 types of errors that you will need to explain and understand in your data set.